Hello everyone, this is Amira. In this video we are going to see how we can build a house price prediction system using machine learning algorithm. So for this prediction system we will be using XG post regression algorithm. So this house price prediction is a regression problem. Let's try to understand more about this problem statement. Then we will discuss what is the approach we will be taking to solve this problem. And then we will get into the coding part. So first of all, let's understand what is the meaning of regression. So generally, machine learning algorithms are classified into two types. They are supervised learning and unsupervised learning. In supervised learning, we will train our machine learning model with lots of data. So we will be provided with labels. So in this house price prediction case, the label is nothing because the price is what we are trying to predict. So price will be our label. So in the case of unsupervised learning, we will be training our machine learning model without this label. Okay, this supervised learning is further classified into classification and regression. So you can see what is the mean by classification and regression in the slide. So basically classification is about predicting a class or discrete value. Okay, so the previous video, the project video we have seen is about predicting whether the person has a diabetes or not. So this is a classification problem. But in the case of regression, we want to predict a continuous value, a number or quantity. So in this project, we want to predict the house price. This is not some kind of classification. So house price prediction is a regression problem. Let's try to understand more about our data. Then we will see what is the workflow we will be following. Okay, so I have given a sample data for our data set. So you can see the column in this data, and the last column represents the price of the house are in the thousands of dollars. So the first column represents the median income of a specific household, and the second column represents house age, the age of the house, and the third column represents the average rooms, the number of rooms, and the average bedrooms, and the population, and average occupation, latitude, longitude, and here we have the price of the house. So the first 7 column we will training our model using the first 7 column, and the last column that we are trying to predict. So now let's see how we can solve this problem. This is the workflow. First of all, we need this house price data. So what we need is we cannot feed this data directly to our machine learning model. So we need to do a lot of processing before we can do that by following some steps. After getting house price data, we need to do the data processing steps. So in this step, we will feed our data to a data frame, and in this data frame, we will do some processing. So by the processing, our data will be suitable and compatible to feed to the machine learning model. So once we process the data, we have to do some basic analysis on the data. So we need to find the correlation between various features. So we have seen that the data set has 8 columns. So we can try to see which of these 8 column features are interrelated, so that we will be doing in the data analysis step. So once we have some basic data analysis done, we can split the data into training data and testing data. Okay, this is called a train test split. So we will feed this training data to our regressor algorithm, and we will evaluate our model with the help of testing data. The training data has to be done with one type of data, and the testing data has to be done with the new data. That's why we are splitting it. So, and XG post regressor is a decision tree kind of classification algorithm. It's very much useful for regression cases. So this is extreme post regressor. We need to predict a continuous value or a numerical value, which is the price of the houses. We use the regressor model. So this is the workflow we will be following. So now let's get into the coding part. First of all, you will need to install Jupyter Notebook. After install Jupyter Notebook, you will press on File and New Notebook, and you will get a new notebook. In the new notebook, first of all, you need to install your dependency, your library. We will need this library. So to install these libraries, just write pip install and the name of library. Try to install NumPy and Pandas, Matplotlib, cPorn, and Sklearn, XGBoost, and Scikit-learn. After installing all libraries, we want to load our data. NumPy is useful for matrices, and pandas is useful for creating a data frame. Matplotlib and Seaborn is useful for visualization our data. sklearn.datasets to import our datasets. sklearn.model selection import train test split. We will use this function to splitting our data into training data and testing data. xgpost import xgpost regressor. This is our machine learning algorithm that we will use to load our model. We will fit our data using this machine learning algorithm. From sklearn import matrices. We will use this matrices to get the R2 score error and mean square error. To get this R2 score and the mean absolute error, we will use this matrices to get R2 score and mean absolute error. So to load our data, we will import fetch California housing from sklearn to datasets. To load our data, we will make a variable house price dataset. To load our data, we will pass the fetch California housing. To see what had been stored in this variable, just print house price dataset. You will see something like this: data and arrays, some values and target, feature name, house age, average room, average bedroom. So we need to convert this data into a data frame. To convert our data into a data frame, just write bd. This is the abbreviation of pandas.dataframe. This will help you to create a data frame. So just write bd to data frame and the name of your data, house price dataset that we have loaded here, house price dataset dot data, and the column of this data to make the columns like this, and the values listed in each column. So this is our data. We need to name this data by its column's name. So the columns will be equal to house price dataset dot features name. So if we want now to see our house price data frame, dot head will let you to see the first 5 rows of our data frame. Here is our 5. We have here the name of the columns. We get the name of the columns from this house price dataset dot features name. So we have here stored the name of each column in the columns and the data here. And creating a data frame will set the values to its here column. So here it is our data. Median income represent the median income of households, and house age represents the age, average room represents the number of room, average bedroom represents the number of bedroom, average population and average occupation, altitude and longitude. To add the price to our data frame, just write the name, price. We want to add a price column, so we want to mention our name of the data, house price, and write price column equal to house price dataset dot target. So this target represents the price of the houses. So this target means the label of this dataset, and this data represents all the other 8 features. So our data now become more structured. To check the number of row and column in the data frame, just write the name of your data frame, house price data frame dot shape. Dot shape will give you the number of row and the number of column. This is the number of row, and this is we have 9 columns. We need to check for missing value. Just write the name of your data frame dot isNull.sum. isNull checks for null value. Null value mean that we don't have a value for our cell. .sum will get the number of null value in each column. So we have 0 null value for median income, 0 null value for house age, 0 null value for average rooms, 0 null value for average bedrooms. All columns we have 0 null value, so that we don't need to cleaning our data because it's already cleaned. We don't have missing values. So now we can get some statistical measures of our dataset. Just write the name of your data frame to describe, and you will get the count of your data frame and the mean of your data frame and the standard deviation and the minimum and the maximum. So this will give the various statistical measures. As you can see here, for each column we have the count. So a count represents the number of data points we have. So totally we have. So these are some important statistical measures. To understand our data set better, now we need to do some more data analysis step here. For that purpose, we need to find the correlation between the data. So I have made a text here, understanding the correlation between various features in the dataset. We have positive correlation and negative correlation. So basically there are 2 types of correlations: positive correlation and negative correlation. So correlation basically represents the relation between 2 variables. So in this data set we have various features or various columns. So we need to find how these features are correlated with each other. Let's say, for example, we need to check the correlation for the first column. which is median income. To get the correlation, just write house price data frame.core. Cores, it's abbreviation for correlations, and we will store the correlations into the variable correlation. To constructing a heat map to understand the correlation, just write plotted figure. Figure size will be in the dimension 10 width and 10 height. So we will constructing a heat map, just write snc.heatmap, and the first parameter will be correlation. The second parameter will be c bar equal true. We will constructing a heat map to understand the correlation. So we are creating the heat map for this correlation value. So this c bar represents the color bar. Color bar is equal to true. So true means we want that color bar in the side. So this is the color bar, as you can see this. So it has various values starting from +1 all the way to negative value to -6 and -7. Positive value means positively correlated and negative element means negatively correlated. Positive correlated values means that when element increase, it also increase. Negative correlated means when element increase, the other element decrease. So this is the positive correlated and negative correlated values. So the third parameter, square equal true. We want all values to be mentioned in a square. And the FMT means how many float values do you want to be mentioned. .1 means like I want one value after the decimal point. So see here, I have 1 after the decimal point, I have a 3 after the decimal point. All values are one value after the decimal point. So you can see there is one value after each decimal point. So if I give you 2 here, it will give you 2 values after the decimal point. So that's why we are using FMT parameter. So the next parameter is annotation equal true. So these are annotations. As you can see, all these are annotation. Features name and all values inside are annotation. And here I have mentioned the annotation size. So basically annotation is all the values and all cells here. It's all features name and all values inside this cell. All these are annotations. So if I increase here the size will be increase of this text, and the numbers, the characters will be also increased. And the next parameter cmap equal to blue. Here I have mentioned the color of our heat map will be blue. Here, as you can see, the maximum value for correlation is +1, and the minimum value for our annotation is -0.75. The square of the color white means there is no correlations between this relation. So this is no correlation between latitude and longitude. That means if latitude increase, it doesn't affect the longitude, and if longitude increase or decrease, it doesn't affect the latitude. And the square that is darkened blue, this means positive correlated. As you can see, 1 is have this color, and here we have the same color. This means we have positive correlated. So medical income, when medical income increase, it also the medical income increase. And when the medical income, here we have a color, it's tends to white, so it tends to negative correlated. That's mean when house age increase, the medical income decrease. So dark color represent more positive correlation, and more white in color represent more negative correlation. So this is how you can find the correlation between various features in a data set through each map. Okay, this is very much useful for data science analysis, where we need to understand the data more better. Okay, so this is how you can create a heat map. So we have created a heat map. Now we need to split the data into data and labels. So here in this case, the labels are nothing but the price of the data. Okay, so we need to feed this data and label separately to our machine learning algorithm, and through that it can find the pattern between the price and all the data. And this is how it's going to learn from the data. Okay, so now let's separate the data into data and label. So let's make a text here separating the data and the target, and press run. So I will create 2 variables, x and y. So in the x is a variable x, let's include all the data, and in y let's include all the prices. Okay, so let's mention the data frame. So the name of the data frame is house price data. We will include our data except the price. So we will drop the column price and we will mention here axis equal 1. If we are dropping a row, we will make this axis equal to 0. And if you are dropping a column like we are doing here, that's why we are mentioning the axis to equal 1. Okay, now we need to store all the labels in the variable y. So what we will do is we will mention the data frame name, the house price data frame, and we will need to mention the column price. So this will store the value of the price column in the variable y. Okay, so I will run the cell now. Let's try to print the variable x, the variable y. See, we have all the data except the prices in x-axis in the x variable, and only the price into a y variable. After that, we need to splitting our data into training data and testing data. So we need to create 4 variables: x train, x test, y train, y test, and we will mention the train test split function. We will pass to this function 4 parameters. The first parameter is x. X is the variable that we have stored all our data frame except the prices, and y is the variable that we have stored the prices in this variable. So the third parameter, we need to mention the test size. So test size is equal to 0.2. So 0.2 represent I want 20% of the data to be in the test data. So 80% of the data will be in the training data. The next parameter, we need to mention the random state equal to 2. So if you use the same value 2 while you are doing this programming, your data will be split into the same way my data is splitting. So if you are using the value as 1, your value will be, your data will be split in a different way. So if you want to reproduce the code, if you want to reproduce how this is splitting is done in the same way, you need to mention the same random state value. So the labels of this data will be stored in the y train, and 20% of the data will be stored in the next y test. So it can be done with the function train test split. So we need to mention the x and y. So we have splitters the x and y here. Now let's see how many instances are in index test. So access the original data, say x dot shape, x train dot shape, x test dot shape. So let's see how many values are there. After running the cell, you will get the number of rows for our original data frame, and we have this number of rows for our splitting data for training, and we have the number of rows for our splitting data for testing. See, the number of testing equal to 20% of our data frame, and the number of rows for our training data is equal to 80% for our data frame for the number of rows. Now we need to loading our model, because we need to train our model. So before we training our model, we need to load our model. So we will loading our model XGB regressor, and we load our model and storing it in the variable model. And to training our model with our data, we will pass to our model.fit function. We'll pass this function xtrain and ytrain. After that, we need to evaluate our model. We need to see the prediction for our training model. Just write the name of your model that you have fit to our data. Mention here the name model dot predict, and pass a parameter xtrain to our predict. What we are doing here, we are predicting the value that we have training the model. We have training our model with training data, and we are testing our model with also the trained data. We just want to see what is the accuracy of our model, what is the squared error for our model. So if you want to see the training data prediction, it will print to you each value he had predicted. So in the previous video, for classification problem, we have used the accuracy score as the evaluation metric, but we cannot use the accuracy score for regression problem. So basically, what we will do in accuracy score is we will check for count the number of correctly predicted values by the model, and the original value. So we cannot find the accuracy score for regression model, but we can find the R-squared error and mean absolute error. So let me show you how you can find those matrix. So we need to compare the prediction of the model values and the original values. So to find R-squared error, we will store R-squared error in the variable score1, and to find R-squared error, just write matrix dot R-score, and we will pass to this function two parameters. Y train, this is our original data, and training data prediction, this is our prediction. And we will see the difference between this our original data and the prediction of our data. We will store this prediction in score1. To see the score1, just write print score1. See, we have 0.94. This is our squared error. To find mean absolute error, just write matrix with mean absolute error, and the same thing, we will pass to this function the two parameter, our original data and the training data prediction. And to see the score2, just write print score2, and this is our mean absolute error. Now we will make our prediction onto the testing data, and this is the important part that we need to do, because the training data, our model is already training on it. He have seen it before, but testing data, he didn't see the testing data before. So our evaluation now is depending on the testing data. So to test our data, the same thing that we have done for the training data, just write model.predict, and the thing we have changed here is X test. That's why we want our model to predict the testing data, not the training data. To find the R-squared error, just write matrix.R-squared, and we will pass to this function the y-test data. And y-test data is our original data, but the data that the model have not seen before. And the test data prediction, this is the testing data that he have predict. And to find mean absolute error, just write matrix with mean absolute error. And the same thing, we will pass our original data and the test data prediction. And here's our score. See, the score of R-squared error is less than the training data. Here's our project, house price predictions.
Hello everyone, my name is Amira. This project aims to group customers of a retail store based on their purchase history using the k-mean clustering algorithm. In this video, I will show to you how to use k-means clustering algorithm. You can download the data from this repository, this file, mailcustomers.csv file. We will build a system to cluster customers into different groups. So, for example, we have clustered the customers into 5 groups. Say that 20% of customers have purchased something, and 10% of customers have purchased another something, and another example that some clusters of customers don't purchase anything. So that is the result of our customer group. So having these groups of customers will give us better insights and details that help you to make better decision making or better marketing strategy and so on. So this is an example of cluster machine learning project. Clustering algorithm is unsupervised learning. Now let's try to understand the workflow which you are going to follow. First of all, you need to download this customer data so that we can feed our data directly with our machine learning model. The next thing, data processing. We need to process our data so that we can get the features which we are needed to train our machine learning model and get the clusters group. Based on the features you have get from preprocessing. Then we need also to analyze the data to see which features are important to us and what features are not important to us. Such kind of things. After that, we need to choose the current number of clusters. So what is cluster? Cluster is when you tell your machine learning model cluster our data into 5 groups or 4 groups or 3 groups. So first you need to know how many clusters you want to cluster. That means you want to split your data into how many groups. So we find that number by using WCSS, which stands for within customers sum of squares. So we will try to find this WCSS value. It tells us the current number of clusters. We will implement this in the code. Once we have the number of clusters we need, we can feed this data to our k-mean clustering algorithm. So once you feed this algorithm with the number of clusters, it can group your data into number of groups that you have from WCSS, depending on the similarity between groups. And finally, we will visualize this. We will draw the visualization using matplotlib library that will draw each group he had cluster. So this is the workflow which we are going to follow. So now let's get started with the coding part. I will do this programming in Python. Programming. First of all, if you are using Windows as a operating system, you need to write this part of code. Import OS syntax os.environment obnum3 equal 1. If you don't try this part of code, you will get that error. Warning, key means is have to memory leak on Windows. So this issue will be solved if you write this code. Now the first step which we need to do is import the dependency, so that we will import this library that we will use in this project. Import numpy as nb, so this is useful in making numpy arrays. Import pandas as bd, this is useful in making data frame. We will use this library in loading our data. Matplotlib and seaborn are useful in visualizing our data. From sklearn.cluster import key means, this is our algorithm we will use to cluster our data. So this is the dependencies which we are need. So to run the cell, just write shift and enter. See, this number means that your cell have successfully run, and if this number is a star, it means that your cell is still running, and if your cell is in yellow, it means that this cell it haven't hand run yet. So the next step is about data collection and analysis. We will load our data here. We will load our data using pandas. We have import pandas as bd, so we will use bd instead of writing pandas. Just make any variable name here to store your data, and then to load your data, write bd.ratecsv and the name of your data. This data you can download from this repository, from this, and the file mail customers.csv. If you want to see only the first row in your data frame, just write the variable you have stored the data in, and then .head function. It will give you the first 5 rows. We just want to see what was the data about. It's include customer ID and gender and age and annual income and spending score. Now let's try to find how many rows and column in this data frame. Just write your name of your data frame you have stored in df.shape. This function will write to you the first index is row and the second index is the number of column. So totally we have 200 number of rows and 5 number of columns. So this is the shape of our data set. Now if you want to get some more information about the data set, just write the function .info and the name of your data frame. So we have 200 entries and 200 row, and data column total 5 columns. So we have 5 columns, and the features in the column customer ID and gender, age and annual income and spending score. And it tells you also the non-null value. Non-null value means there is no missing value, and the type of each column, the type of customer ID is int, and the type of gender is object, and the type of age is int, type of annual income is int, and the type of spending score is int. And also we can get more information about the missing values in our data set. Just write the name of, mention the name of your data frame, and is null function .sum. Is null function it checks for the null value, and .sum it will get the sum of number of values you have missing in your data frame. So because we don't have any missing value, we all have non-null value. That's why we get the sum is 0 here. So this line of code will show you the number of missing value in your data frame. So now we need to choose which column. We need to make clustering based on the column we choose. We can see here we totally have 5 columns. Customer ID, so we don't want this customer ID because it's not required. We are going to group our customer based on spending score and annual income. So we are going to classify our group customer based on these features, annual income and spending score. So now I'm going to choose these 2 columns alone. We will doing this by write your data frame .iLocations because we are going to locate a specific 2 columns, and we write column here because we want all rows, and for column section write only from 3 to 4 because if we come back to the data frame, counting in Python starts from 0. So customer ID is 0, gender is 1, age is 2, annual income is 3, spending score is 4. So that's why we write here 3 and 4. So after that you slice your data frame, just write .value to get all values of just 2 columns. And if you want to see the values you have sliced, write X that you have stored the 2 columns. You will see this 2 columns, right? See here, the first value is 15 and 39. If we come back to the data frame, we see 15 and 39. So this is the value of 2 columns. The next step is to choose the number of clusters. We will choosing the number of clusters by choosing a parameter, and this parameter is WCSS. We can find within cluster sum of square by using this formula. Tends to find the distance between each data point and their centroid. So you can see here each cluster represents a data point. So this point is near from this centroid and this point is near from centroid. So he make cluster for this group and he finds some point here and he sees that all this point is near from each other, so he makes this centroid here, and based on that he see what other point is near from this centroid. Based on that he make cluster this group, and the same for this point. For finding the WCSS value, we are building a plot like this. This is elbow graph. So this graph shows you which number of clusters has minimum WCSS value. That means which number of clusters has the least value difference from centroid and the point. So in this case, we're going to create a for loop in each cases. So in the first case, we will find the CSS value considering for one cluster, and we will do it for 2 cluster, and then for 3, and then for 4. All the value till 10 clusters, and in this 10 cluster, we will try to find which number of cluster has minimum WCSS value. So we will create here an empty list WCSS. So we'll make for loop here for I in range 1 to 11. This will take the value from 1 to 10. That means we will search for the number of clusters from 1 to 10 that has minimum WCS value. So this loop is iterate from 1 to 10. After that, to find the number of clusters which has a minimum WCSS value, we will make a variable named keymeans, which we will load our algorithm keymeans, and this keymeans gets 3 parameters. The first parameter is number of clusters. We will equal this variable to I. I is the for loop from 1 to 10. So number of clusters, the first loop it will be 1, the second loop will be 2, and the third loop will be 3, and so on. And second parameter is init equal keymeans plus plus, and the third parameter is random state. So you can give this parameter any value. I will give this parameter 42. After that, we will fit our data with this keymeans. What data we want to fit? We want to fit our data with keymeans for this only 2 columns. So that's why we have split our data and taken the column 3 and 4, and we store this 2 column in x variable. So we will fit keymeans with this x variable. So we wanted to append the keymeans inertia that we will get from this line into the list we have just created here. So that we write here wcss.append keymeans inertia. We will plot the WCSS values. So when you write this, it gives you the WCSS value for each cluster, and it will be stored in this list. So now we need to graph the value of WCSS that's stored in the WCSS list to determine the minimum value of WCSS. So that we will plot an elbow graph by writing here say snc.set. snc is the abbreviation of the library cboard. When you write this line, it means that you set the parameter of the graph, and we will plot our graph in the range from 1 to 10 and write in this range the WCSS value, and we will title our graph the elbow point graph that we have done here, and the x label will be the number of clusters, the x label number of clusters, and the y label will be WCSS in the y label. And then to show the graph and appears to you, write plot.show, so the graph will be shown to you. So now if we analyze this graph, we will see a cutoff here that stands for 3 clusters, and then if we continue, we see another cutoff here which stands for 5 clusters. So now we have 2 elbow points, 3 and 5. We will take this 5 value. So we have optimum number of clusters is 5. So now we have the number of clusters. We use this number of clusters. So now we will training the keymeans clustering model, and in this case the k is equal to 5. So we'll write again this line, but this line we now have the number of clusters, so we write keymeans number of clusters equal to 5 and initialization equal keymeans plus plus, and again the random state we will mention any number you want. I will mention here 0 number. After that we need to return a label for each cluster. So what we are going to do, we are going to take all the value from this particular dataset, these 2 columns that we have split it from the dataset, and we will give them a label. After we cluster them, each point is now in a group of clusters. So we have 5 group of clusters, so each point is now have a label. We'll have a label 0 or 1 or 2 or 3 or 4 because we have 5 clusters. After that we will visualize our clusters. So we want to know each point of this x value which is contained in any of these clusters, 1 or 2 or 3 or 4. So we write this line here, keymeans.fit predict x. This is our value which has the 2 columns we have split from our data. After that we will print y, and this is the labels we have just, and this is the label. After that we need to visualize our cluster. So our figure will be in weights of 8 and a height of 5, weights of 8 and a height of 5. After that we wanted to graph each point in its group cluster. That's why we have right here plot.scatter x y y equal 0 0, x equal y y 0 1, s c equal green, label equal cluster 1. What does this line mean? X, this is our data which contain the 2 columns, unknown and depending score, and y equals 0 0 0. The first index is represents the number of clusters. So the first index represents the cluster 1, and the 1 represents the cluster 2, and the 2 represents the cluster 3, and the 3 represents the cluster 4, and 4 represents the cluster 5. The second column represents the unknown. Because we want to graph these 2 columns, the first column is unknown and second column is depending score, and we have stored these 2 columns into the variable x. So x now contain only these 2 columns columns. So the first index of x is representing the annual income, and the second index 1 equal to spending score. So that's why we write in this all columns 0 and write in these columns all 1, because we want to graph all the points in these two columns into each cluster group. So the first index represent here the number of cluster group, and here represent the first index represent the number of cluster group, and the second index here represents the annual income, which is index 0, column 0, and the second index here 1 represents the spending score column, and s equal 15, which is set to the size of the scatter plot equal to 15. Cluster 1 equal be green, and the number of cluster and the red and the color of cluster 1 will be green, and the color of cluster 2 will be red, color of cluster 3 will be yellow, color of cluster 4 will be violet, color of cluster 5 is equal to. So now we come to an agreement that x represents the annual score and this represents the spending score, which is this graph the point in annual income in x-axis, and this will graph the point in spending score. We'll graph the value in spending score in y-axis, and we'll cluster each one in each group it's contained. So this is will the result. It will draw each point in each group, and x label will be annual income, and y label will be spending score, and the title will be customer group. To draw this centroid in each cluster group, we write plot.scatter key means cluster centers. We want to draw centers for each two columns, so we want to draw center for the one column, which is index 0, and the two column, which is index 1. So the first thing we select all the row, and the second index is 0, which represents the first column, and key means the cluster centers, which here we are drawing center for the column 2 and all rows, and the size of the scatter will be 100, and each color will be cyan, and each label will be centroid. Here is our graph. This graph shows us that from 20 to 40 annual income, cluster group has minimum value spending score from 0 to 14, and we have another cluster group which have higher annual income from 18 to 100, but also have low spending score. So from these two groups we can give them a discount to get high spending score. And also we have a cluster group here from 14 to 80 annual income and from 40 to 16 spending score. So this group is not much high spending score and not much annual income, it's medium between them. And we have a group here which have a low annual income but high spending score, and this group have high annual income and have also high spending score. So this is all the project, and thank you. Hello everyone, this is Amira. In this video we are going to build a machine learning system. Okay, so we will be using one of the important machine learning algorithms, support vector machine. First of all, let's try to understand about this support vector machine algorithm. So this is one of the important algorithms of supervised learning algorithm. So in supervised learning, we feed the data to our machine learning model, and the machine learning model learns from the data and its respective labels. So here the labels are the most important things. So what happens in this case, we train our model with several medical information such as blood glucose level and the insulin level of the patient, along with whether the person has diabetes or not. So this acts as labels whether the person is diabetic or non-diabetic. So this will be the label for this case. So once we feed this data to our support vector machine model, what happens is it tries to plot the data in a graph, and once it plots the data, it tries to find a hyperplane. So in this image you can see the hyperplane. So what happens is that this hyperplane separates these two data. So once we feed a new data to this model, it tries to put that particular data in either of these two groups, and by that it can predict whether the person has diabetic or not. So in this case we use several medical information such as BMI of the patient and their blood glucose level and their insulin level and etc. So now let's try to understand the workflow for this project. So first of all, we need this diabetes data. You can download it from the link of the GitHub repository that I will give you. We'll try to train our model with that data and the respective labels. So before feeding this to our model, there are a lot of steps in between. So the next step, we need to pre-processing the data, where we will try to analyze the data. This data wouldn't be very suitable to feed to the machine learning model, and we need to standardize this data because there are a lot of attributes here and a lot of medical information, and we want all this data to be in the same bridge. So what we do is we try to standardize all this data so that all this data lies in the same range. So all these things will be done in the data processing. So once we process the data, we will split the data into training and testing. So we will training our machine learning model with training data, and then we will try to find the accuracy score of our model in the help of test data. It tells well our model is performing. So once we split the data into training data and testing data, so we will feed this to our support vector machine model. So we will be using a classifier model. This model will classify whether the patient is diabetic or not. So once we have trained it, we have a trained supported vector machine classifier. So when we give a new data, it can now predict whether the patient is a diabetic or not. So this is the workflow we will be following for this project. You can download download the coding file and the data from this repository. So now let's get into the coding part. First of all, we will import all the libraries that we will need during this project. Import numpy as np. This library is useful for matrices. Import pandas as bd. This library is useful for creating data frame. We will use this library to load our data. From sklearn.preprocessing, import a standard scaler. This standard scaler is used to standardize the data to a common range. After that, from sklearn.model selection, import train test split. We will use train test split for splitting our data into testing and training. And from sklearn, import svm. svm is a support vector machine algorithm in machine learning algorithm, and this is a supervised machine learning algorithm. Support vector machine is using for classification or regression. If you use support vector machine as a classification, just write svc. If you use support vector machine as regression, write in the code svr. And from sklearn.matrix, import accuracy score to get the accuracy of our model. So to run this, just write shift and enter. Now we will do our data collection part. You can download this data from this website. To load your data, just write pandas.readcsv and the name of your data, diabetic.csv file. And to store the data that you have read here, store it in a variable diabetes dataset in the variable diabetes dataset. If you want to see what our data is about, just write the name of your data that you have stored in this variable .head. It will give you the first 5 rows in the data. This dataset includes the data for all the females, so you can see here the number of pregnancies, glucose level, blood pressure, skin sick, and insulin, BMI diabetes. BMI stands for body mass index, which is basically calculated by dividing the weight by 8 square. And then we have diabetes pedigree function, which is basically a number which indicates some diabetic value. Then we have age, then we have outcome. 1 represents that the person is diabetic, 0 represents that the person is non-diabetic. If you want to know how many column and how many row in our dataset, just write your name of your data frame .shape. It will give you 568 row and 9 columns. If you want to get more information about the data, a statistical measure of the data, just write the name of your data and describe. It will give you the count and mean, standard deviation, and minimum and max. The aim from our project is to make a predictive system that from this data will predict that a person will be diabetic or non-diabetic. At the end of this video, we will get any data from this data, for example this column, and we will not get this outcome, and we will test this row and wait for the model answer to tell us if the person is a diabetic or non-diabetic. If you want to know in this out how many persons are diabetic and how many persons are non-diabetic, just write the name of your data set and the name of your column outcome.value count. It will give you 0. The number of 0 is 500 and the number of 1 is 268. So that we have non-diabetic persons 500 and have diabetic person 268. Non-diabetic represents 0 and diabetic represents 1. If you want to get the mean value for persons who diabetic and non-diabetic, just write the name of your data frame .groupie, the name of your column outcome.mean. It will give you the means for two values 0 and 1, all the means for persons who are diabetic, for persons who are not diabetic, and persons who are diabetic. It will give you the mean value of pregnancy, glucose, blood pressure, skin sickness, insulin, and BMI, and the rest of your column. So this difference is very important to us because this is what machine learning algorithm will see and detect, that if a person has this kind of values, for example, if a person has a value in the range of 13, so this person will not be diabetic. Another example, if the blood pressure is in the range of 70, this person will be diabetic. So these are some important insights we can get from this data. If you want to separate the data and labels, we want to remove this column outcome and store it in a variable and store another column in another variable. So that is what we have done here. Diabetes data set, the name of your data frame, the drop columns equal outcome axis equal 1. This line means that you have deleted the column outcome from your data and store it in a variable x. The next line y equal diabetes data set outcome, that means you have to store the column outcome in the variable y. If you want to see the values of x, just write print x. It will give you all the column except the outcome. If you want to see y, it will give you the value of the outcome axis equal 1. That's because you have dropped a column. If you want to drop a row, just write axis equal 0. After that, now we are going to do is standardize our data. This is one of the important steps in data processing. Just write the standard scalar function and store it in the variable scalar. Now we want to fit this data in this scalar. Just write scalar.fit and pass your x variable. X variable that you have stored your data except the outcome. Now we need to standardize the data. Just write scalar.transform x and store that in the variable standard data. So basically what we are doing is fitting all these inconsistent data with our standard scalar function, and based on that standardization, we are transforming all the data to a common range. So this will give the data in the same range. If we print this standardized data, we got this array. As you can see here, all these values for the range of 0 and 1. This will help our model to make better prediction because all the values are almost in the same range. We will give this standard data that we have created to a variable x and the column outcome to a variable y again. If we print the variable x, we will get the array that we get before, and if we print the value of y, we will get the column outcome. We will use this x and y for training our machine learning model. So basically x represents the data and y represents the model. Now we will split our data into training data and test. To split that, we will write x train, x test, y train, y test, and write the function train test split. It takes 5 parameter x, and this is your data, y is your model. Test size that you 0.2. That means you will split your data into 20% for testing and the other for training. Then we will stratify based on y. So basically y is the values 1 or 0. If we don't try this stratify equal y, maybe all the cases for diabetic will go to one data frame, and maybe non-diabetic cases may go to x. So that is the reason we are using stratify y equal y. And then we have random state. We set random state equal to 2. Let's say for example you are making this similar code and you want to split the data in the same way I did. So in that case you need to mention the number 2. So if I mention the number 1, the splitting of data will be different. So if you want to replicate that split, you can represent 1. So now we will see the shape of our data, x train and x test. X is our original data. X.shape will give you 768 row and 8 column, and for x train.shape will give you 613 row and 8 column, and for x test.shape will give you 154 row and 8 column. Now we are going to train our model. We will training our model using SVM. Because we are using SVM support vector machine here as a classifier, we will write .svc. SVC stands for support vector classifier, and we will choose the kernel equal to linear. Support vector machine has other kernels, like each kernel has its pros and cons. This will load the SVM model to a variable classifier. Then we will training our data by using this classifier. Just write classifier.fit x train and y train. This is the data that we want to train. Basically what we are doing here, we are fitting our data with this classifier. Now we will evaluate our model. So first let's try to find the accuracy score on our training data. But before that, we should predict our x train data. To predict our x train data, just write classifier to predict x train data. And if you want to find the accuracy score, just take x train prediction, the variables that you have stored classifier to predict x train here, and the second parameter will be y train data. So we will try to predict all this training data. So we will compare the prediction for our model to the original label. So we are comparing the x train prediction with the original label y train. Run this and you will get the score is 0.7866, and this is good score. We will do the same thing for our testing data. Just write x test prediction to store our predicting x test. Just write classifier to predict our x test data, and we will store it in x test prediction, and we will apply the function accuracy score to our x test prediction with our original data y test. This is the important step because the model has already seen the training data, because basically we are training the model with the training data, and it doesn't make sense if we only evaluate our model based on that training data. So we need to use the model to predict some unknown data. That's why we make accuracy score to our testing data. This data he hasn't seen before. It tells us how our model is performing. Now we will making a predictive system. We will give our model just this column, the value of this column, and we will not give him the outcome. He will predict the outcome. The result he should tell us if the person he is diabetic, if the person he is diabetic or not. We will open our data with Notepad. Just write open with and choose Notepad. For example, I will get this data except the 0 and copy this and paste it here and store them in a variable input data. We will convert this input data to a numpy array. Just write numpy.asArray and input data as a parameter. After that, we will reshape our data. So what is the reason for this reshaping? That's because our model is trained on 768 examples, and there are totally 8 columns in our model. But in this case, we are just using one data point. We don't have 768 rows. So if we don't reshape the array, what the model expected? It expected 768 rows, and you are giving him just one row. So this will make confusion to our model, and hence we need to reshape the array. And this reshape will tell the model that we are just going to need the prediction for only one data. So that is the reason for reshaping. After that, we will do the same thing that we have done before. We need to standardize our data. First of all, we need to apply scalar.transform input data to reshaped, that we have reshaped data here, and we will store it in a variable standardized data. Then we will make prediction. Just write the classifier.predict our standardized data and return the prediction. If the prediction equal to 0, that means the person is non-diabetic. That means the person is not diabetic. And if the prediction is 1, that means the person is diabetic. And if we see the result is 0, that means the... Hello everyone, my name is Amir. This project uses a machine learning technique called support vector machine to help doctor classify human cell samples into two categories: benign, and this is not harmful, and malignant, and this is harmful. This classification helps in diagnostic disease like cancer based on characteristic of cell samples. Support vector machine is a powerful machine learning algorithm used for linear or nonlinear classification, regression, and even outlier detection tasks. We are using SVM here to classify cells whether the samples are benign or malignant. First of all, we should import our necessary library, import pandas as PD. This library is useful for creating data frame, and we will use it to load our data. Import numpy as NB. Numpy is useful for matrices. Import matplotlib.pyplot as PLT. Matplotlib is useful for visualizing our data. If you want to download the dataset, just go to this repo and download this file. In this repo, you will find all the dataset and the code in this repo. So after that, we will load our data. So we will write pandas.readCSV, the name of our data, cell samples.csv. If you want to see what our data is about, just write data frame, the variable we have stored our data here, .head. It will show you the first 5 rows, the features that we are interested in, and we will use it to classify our data. And this is class. This column has 2 values, 2 or 4. See, the column of class only we have the 2 value, 2 and 4. Number 2 means it is a benign. Number 4 means it is malignant. And as we know that benign is not harmful and malignant is harmful. If we want to see the last row of our data, just write your data frame.tail. It will show you the last 5 rows. If you want to know how many row and how many columns, just write dataframe.shape. It will give you this is the number of row and this is the number of column. And if you want to know what is the number of cell do you have, just write your data frame and dot size. It will give you all the cells you have. All the cells means that all number of rows multiplied by the all number of columns. And data frame.count, this computes the number of non-null value in each column in the data frame. And if you want to know what values in a specific column and how many values of this column, just write the name of your data frame and the name of your column class dot value count. It will give you 2 and 4, 458, and the number of 4 is 241. What does this mean? If we come back to our dataset, we see a column name class. This column class has 2 values, 2 and 4. As we said before, that 2 it represents the benign and 4 represents the malignant. So we have the number of benign 458 and the number of malignant is 241. The next thing we will talk about is distribution of the classes. We want to graph these values. As we said before, that benign is the class 2 and the malignant is the class. This is the name of our data frame and this is the name of our columns that we will get from our data frame, and we will split the value 2 from our data frame and store it in the benign variable, and we will take only 200 rows. That means after we stored all the value 2, we will take only 200 rows. And the same for malignant. We will get from column class the number 4 and we'll get only 200 rows. And if you want to graph our benign values, just write benign.plot and the kind of your plot will be scatter, and in the x-axis will be clump unique size and the color will be blue and the label is benign. And this is the graph of our benign values. If you want to graph our malignant value, it's the same thing. Just write malignant.plot kind scatter x clump y equal unique size and color equal red, the label equal malignant. And this is our graph that represents the malignant values. If you want to merge our values benign with the malignant value, just write here ex equal ax. For example, ax, and ax is the value of the benign, and you will store it in a variable ax, and just run this cell and run this cell again. I don't know why the graph doesn't appear, but we can write ax here and run again. Here it is the graph. Our malignant and benign are in the same graph. If we want to see all the type of our column, just write your data frame to data type. It will get all the data type of your column. We are dealing with number only, so this column is object. We will convert this column to int because we are dealing with number only. So this part of code to convert this column to an int. If we see data frame to data type again, it will see this column is converted to an int data type. In our data, we don't need this column ID, and we already have used this column class, so we don't need it also. We just want this column. So if you want to know what is the name of all your column in your data frame, just write your data frame dot column. It will show you all the name of the column in your data frame. As we said, we only want this column, so we'll copy this column and store it in another variable. This variable is called feature. We will make from our data frame this column. We have 11 column. We will get only 9 column from this 11 column. After that, we will convert the feature data frame to a numpy array and assign it to x variable. And if you want to see the 5 entries of the array, just write the name of your x variables that you have stored the array here and 0 to 5. And here it is the array. We have 5 rows. We will convert also class column to a numpy array and store it in the variable y. After that, we will train our model. We have 100 rows. We will divide this number of rows to 80 row for training and 20 rows for test. To train your model, just import the library learning.model selection, import train test split. As we divide the data into training and testing, we write x train, x test, y train, y test, and equal train test split. We will train x. This is the variable we have stored the features, and y, this is the variable we have stored the class. And test size, we have right here 0.2, which equal 20% from our data that we will test, and the rest will be training. Random state, just write any number here. If you want to see what is the number of column and what is the number of row of our x train, just write dot shape. It will give you 546 rows and 9 column, and y train dot shape will give you 546, and x test dot shape will give you 137 rows and 9 column, and y test will give you 137 rows. Now we're using the classifier svm, support vector machine. The classifier svm takes 3 parameters. One parameter is the kernel, 2 parameters, the second parameter is gamma, the third parameter is regularization. We have different type of this kernel. One of them is linear, and we have also polynomial, radial basis function, and sigmoid. The role of this different kernel is to mapping data into higher dimension space. Each of this kernel have its pros and cons and its equation, but there is no easy way for knowing which function performs best with a given data set, so that we usually choose different function and get the result for each function and compare the results. The next parameter is equal to gamma. Gamma equal O2. Gamma equal 1 over number of features. This is the O2 value. And the third parameter is C equal to. This is the regularization. What is the benefit of regularization? We use it to avoid overfitting. And here we are creating an SVM classifier with linear kernels. And here we are training the SVM classifier using the training data x train and y train. And here we are using the trained classifier to predict the label for x test. And finally we will get our result. To do that, we will import the classification report function from the library sklearn.matrices. And after that, we will print the classification report y test, y predict. This prints out the classification report, which includes several matrices such as precision, recall, and support for each class. The report compares the true label y test with the predicted label y predict from our classifier. And this is the result that will appear to you. The classification report provides a detailed analysis of how well your model is performing with respect to each class in your test data. Thank you for watching.